Thank you. Hello, I am Zhang Dong from China Telecom. It's my great pleasure to have the opportunity and share how we have innovatively applied F5G. First, I would like to share that over the last 3 years, amazing 5G use cases have emerged in various industries. Based on the nearly 1,000 use cases, we have identified several trends. We believe the priority is to introduce 5G to the mobile elements. Mobile elements include people, vehicles, and things on the move. The industries with operation procedures can benefit from 5G. In our opinion, there are 4 types of use cases. First is to use 5G to enable high-speed mobility. Typical applications of this category include autonomous driving, remote control of vehicles, remote management of ports or warehouses, and AGVs in factory workshops. The second type of use cases is those leveraging the fast uplink and downlink transmission enabled by 5G, which is predominantly related to videos today. In the future, in addition to video, integrated video and other textual form will also emerge. For example, AR and VR are developing fast today. We know that 5G has encouraged the development of multiple industries, such as augmented and virtual reality, artificial intelligence. The third type of 5G use cases focus on scenarios where people and things gathered, such as transportation hubs and places with large number of people or large objects moving around. The fourth types of the use cases is to deploy 5G in hazardous environments. For example, some working environments might expose personnel to toxic gas, to loud noise, or other safety hazards. Then 5G can help to protect people. Based on the 4 types of use cases, we can see that the industry chain will go through 3 stages. The first stage is enhanced sensing and diverse experiences. We can enjoy more diverse experiences because of 5G. The second phase is where 5G provides production assistance, helping to manage personnel and factories. The new generation of the mobile technology might even make a manned plant a reality. Also at this phase, 5G connections are deployed for remote operations. The third stage will witness the upgrade of industrial digital transformation. I would like to show you 3 offerings of customized 5G networks of China Telecom. They stand for 3 different business models. Wingspan and adjacent modes are more common. They are the 2 offerings we have. They can be used in healthcare and industry, manufacturing. Let me introduce a little bit more about the 3 offerings. First is Wingspan. This is an offering where cell sites are deployed for industry operations only. Individual users do not have access to them. Practically, a private network is built for production or for, say, a surgical environment. Adjacent mode goes another step forward, as it features edge computing and cloud network synergy. Some campuses, such as an enterprise with branches located not far away from each other, may subscribe to adjacent offering. Wide area is designed for long-distance communication with WAN access and cloud network synergy. The wide area mode has been applied for some use cases. For example, the China Central Television is delivering converged media using a wide area mode. Next, I would like to put things in perspective. 5G is a capability, but it cannot do everything. It simply provides an opener and more advanced way of communications that can empower various industries and introduce innovative use cases. 5G's benefit also include its ability to streamline and optimize the process of applying data, which contributes to the converged innovation across the industry. As I mentioned recently, 5G has encouraged the development of VR, AR, and AI. There has been great progress witnessed in these industries. We look forward to seeing AI, AR, and VR can be applied in more diverse scenarios. Now, let's have a deep dive into the future of 5G. China Telecom believes 5G will evolve in the following four aspects in the next 3 years. First is edge computing. 5G demands higher overhead and computing workload in the edge clouds and the edge data centers. So new domains of technology emerge. We hope to see more companies bring innovations which deployed software, hardware, and chips to make the edge intelligent. Second is the direct communication between machines or between things. When edge computing reaches certain level of maturity, it will remove the automatic control units between two machines, such as the PLC and DCS. A command or execution instruction can be sent from simply one machine to another directly. So, machine-to-machine communication becomes flat. The third trend is the radio lines will be dynamic. 5G enables a different radio line to be created as an object travels away from the previous one and disconnect with it. Radio lines can help to protect data, making sure it stays private. With the technology, a fleet of drones, autonomous driving, the communication between vehicles and roads can be safeguarded. Another trend is the scarce spectral resources will be shared. AT&T in the US has been an exemplary model in the industry. They have tried to adopt multiple bands and consider the use of millimeter wave. In China, China Telecom and China Unicom are addressing the scarcity of spectral resources with efforts to deploy and share 5G cell sites. By doing that, we can make use of the two 100 MHz bandwidths of the two telcos, which practically doubles the width of the radio highway, allowing the speed of transmission to be faster. This multi-band mode is preferred in places such as airports and train stations. In some special scenarios, maybe in some plants, we will also deploy multiple bands on one site. Another point I would like to discuss is F5G. There's a F before 5G. F here stands for fiber connection. Fiber connections and 5G joining hands will usher in another wave of technological innovations. Between 5G base stations, data is transmitted through fiber optic cables. Fiber optic cables are already applied in industry PON, which as of to date can already extend the fiber connections to OT. That means fiber connection can be used to control robots. If fiber connections are deployed together with 5G, mining and other use cases in verticals will emerge. In addition, we know that UPF and MEC of 5G can be virtualized. If fully decoupled, they can be deployed on our ONUs and OLTs, introducing more technologies of software and computing capabilities to the same hardware. As a result, 5G and fiber connections can be supported by the same piece of equipment. Enterprises need less hardware and thus easier O&M. This has become a new driving force for F5G. It will facilitate the development of digital economy. We hope to have more telecom equipment manufacturers Sensor makers contribute to the innovation and diversifying use cases. Let's continue with the deep dive. 5G makes it easier for us to collect data. Data can communicate through network connections. The communication of data, if commercialized, can lead to transformation of an industry. With data communicating, more data models, service models, and algorithm models can be created. A larger market will then come into being. For example, factory management. Apart from using 5G for managing production and manufacturing, the management of sales and logistics will be more refined. The refined management will bring transformation to the entire industry. It will also enable the collaboration between enterprises easier. Another deep dive finding I would like to share is the interoperability of data after it is connected. Data is distributed in different enterprises, departments, and institutes, creating data silos. To address that, we would like to create a new model featuring a unified data space with open source technologies and by secure and trustworthy development. This is the ultimate goal of data interoperability. We also will consider adopting DOIP and distributed database among other technologies to increase the security and trustworthiness of data interoperability. Next, I would like to introduce the implementation of 5G to B with projects. But of course, this is still an ongoing journey. The first implementation is to make a mining site smart. Safety accidents often occurred on mines. There are several pain points that have long been difficult to address. One of them is the dynamics of the underground environment cannot be collected, so site supervisors on the ground are not aware of what is going on under the ground. If there's a new mode of communication that can reach underground and help us monitor the high risks of activities, we'll be able to cope with the dangers without having to go down the mine. Such practice can help to reduce casualties. Another pain point is the misalignment of data on and under the ground, causing misinformed decision making. Moreover, it will lead to inefficiency. For example, when there is an alarm, the operation of the whole mine may come to a pause. When there is a safety accident, the damages can be substantial, and it might even cause other problems. We try to use the explosion-proof F5G technology. We deployed the fiber cables along the ore transportation rails and constructed F5G small base stations for gas data collection on the important work platform. We monitored the whole drilling, mining, and the ore transportation process. The entire process of manufacturing, drilling, and the mining is monitored in the real time. We can see that remote control can be implemented in some of the smart mines or gradually. Communication technology and AI algorithms are used to control the equipment from the ground, including the movement of coal cart. We are going to use more learning algorithms and graph-based algorithms to gradually realize unmanned operations in the well. The second case is from the State Grid Corporation. In fact, State Grid rarely makes such an attempt. The 5G network was used as a dedicated network for the transmission and generation of the power. Many technologies must be validated, as the state grid requires a fully security for power transmission. Therefore, the stability of the 5G private network and feasibility of the time control must be validated. I have listed 5 scenarios that we supported. I'd like to talk about one very important scenario, that is 5G plus smart distributed FA. We use FA to connect the network, and by doing that, we can calculate the power outage period of a city, and we can minimize the power outage period. And that plays a very important role in power distribution and power outage control. That's an amazing innovation. And in the interest of time, I cannot elaborate all on the other 4 scenarios. The third case is about, and I would also like to talk about the data and the 5G. There are different types of use. We will see 5G encouraging data collection, data analysis, data transmission, data flow, and 5G will also encourage AI. So data governance and operation will become key issues for the industry to consider. For example, who owns the collected data? Who can process, analyze, and apply the data? Then, how should the revenue be shared? What is the business model? In industrial scenario, service personnel and experts in the field tend to process data on site, while in the government and the municipal affair, usually data is collected at the level of a city or at a town. So in different scenarios, different standards must be implemented. Another very important point is we must have data scientists to process and gain insights into data. And these data scientists must have know-hows of different domains. If someone is about to process the data of municipal affair, then they must understand something about the municipal affairs or city governance. And 5G, in particular, F5G, cloud computing, and AI will be deeply integrated and enable all industries. We can say that data will drive the digital transformation of the entire industry and enable sound growth of the digital economy.